Okay, so let's just take as an example a to the fourth, b to the seventh quantity raised to the negative 3/4. There are many ways you can do this, okay? So I'm going to do this in a couple of different ways at least and show how they all come out the same. So one way to do this is to say, okay, well that means 1 divided by a to the fourth, b to the seventh raised to the 3/4. And everybody's done that, and that's correct. Well, then I'm going to write it this way. That means 1 over a raised to the 4 times 3/4 times b raised to the 7 times 3/4. Because I'm applying the rule that says, you know, this to a power times this to a power raised to another power is this one to the product of the powers times this one to the product of the powers, right?
Right.
And you know what that rule is, and you've applied it many times. So this would be 1 over, well, 4 times 3/4 is just 3, right? So that's a to the third. And this is b to the 7 times 3/4. Well, that's going to be 21/4. Whatever in the world b to the 21/4 is, that's what it is, right?
Right.
So there it is. Okay?
Okay.
And this is one standard form where you don't have any negative exponents. Okay?
Yeah.
Another standard form is where you don't have any denominators. So I could also write this as a to the negative 3, b to the negative 21/4. Okay?
Okay.
So this is the form with no negative exponents, and this is the form with no denominators. Okay? So either of these forms, depending on what you're trying to do, is a valid form. Okay?
Okay.
You probably don't want to mix forms, although on the homework that I gave you, I never said anything about that, so it was fine to do that, okay? But I'll probably ask you to go back and the forms that have both denominators and negative exponents, change them to a different form. Now, I'll put the instructions for that. It's simple enough. Okay? Now, another way to have written this whole thing out, okay? The laws allow this also, right?
Mm-hmm.
You don't have to do a reciprocal. You don't have to apply the fact that a negative exponent just puts everything in the denominator, right?
Right.
And gives you the positive. So I can just directly apply the law to get this, and that equals a to the negative 3, b to the negative 21/4. Okay? And it gets you this form immediately, with
Okay.
fewer steps.
Yeah, I like that one better.
Yeah, yeah, you probably will. Although nothing wrong with this, because this is very detailed, and it uses, every step uses one of the laws.
Right.
Okay? So you get down to this. And you could also write it as this. Okay? This is a form with no denominators. This is a form with no negative exponents. Okay? And there's even another form. If you do the form with no negative exponents, you can then easily write it in radical form. Well, a to the third doesn't need a radical, but b to the 21/4 is the fourth root of b to the 21st.
Okay.
Does that make sense? Because b to the 21/4 equals b to the 1/4 raised to the 21st power, right?
Right.
And b to the 1/4 is the 4th root of b raised to the 21st power. I could write it like this, right?
Mhm.
Or b to the 21/4 could be written as b to the 21st raised to the 1/4. Okay?
Okay.
Which is the 4th root of b to the 21st power. So these two forms are the same radical form.
Okay.
Now in my class, we don't do a lot with radical form, just because I rely on a lot of typed out stuff, and I pretty much stay with this. But you do need to know the conversion between radical and fraction form. Because in your course, especially, that you'll probably see it. I mean, my students are going to see it also. I don't emphasize it all that much.
Okay.
It's also something that you would see, I forget, in the MTE 8 or 9. I'm not sure. I don't remember where that lies, but I know it's in the material that we need to cover, so we need to talk about that. So I'm going to ask you to put some of these into radical form as well.
Okay.
Okay? But on the whole, you've applied the rules correctly, and I don't see any errors. So 2 thumbs up.
Thanks.
Okay? Very good.